Hi, Stu H on the Facebook group, Hard Boils on the Homebrew Forum. Just a really quick video today just to talk about water chemistry. I'm brewing a wheat beer this weekend, so thanks for the suggestions on the Facebook group. I put a thread up just saying what are you brewing this weekend, and somebody said they were doing a wheat beer, and actually it's been on my list for a long time, so thanks for sort of putting that out there. That was a good suggestion. I'm going to give that a go. There's some amazing suggestions on that thread. Actually, I'd love to brew pretty much everything on there, so I'm definitely going to be tapping people up for some of those recipes once they've had a chance to perfect them. So what I'm looking at doing today is just confirming and adjusting my water just to meet the water profile for the different beer types. There's a couple of ways you can go about working out what your alkalinity is. That's one of the main kind of variables you need to do. A couple of very simple adjustments which I'm going to talk you through, and you can download your water report, which is available online. If you go to your local water company, Thames Water, Southwest Water, Scottish Water, etc., you should be able to find a water report. And I've actually found this to be pretty close to what you need in terms of I have actually gone in the past to the extent of getting my water report done by Phoenix Analytics, and it actually came out very close. When you're doing your beer style calculations for your water, there is always a band that those beer styles, a band of alkalinity or calcium, whatever that's required for that beer style, and that band's wide, so there is a little bit of room for flexibility. Yeah, my water report was reasonably close to what the actual figures were on the report that the water board gave me. I think for a specific example here, my total alkalinity on the actual report that I had commissioned and had done was 200, and it was 244 on the waterboard's alkalinity report. And then bear in mind for most beer styles you've got quite a wide band, so shall we say for calcium it's 180 to 220, so if you're doing a bitter or a pale ale. So I think you can see that there's, it's certainly going to be better than it was. So even making small sort of gradiated steps towards where you need to be, I think is a good thing. And of course you can adjust your water and then use a kit like this to retest it. So this is a really good way of just like dealing with seasonal variations, or if you just want to check that the water you've adjusted, is it within band, you can use a kit like this, or you can use a kit like this to create a baseline for your alkalinity effectively. And this is for saltwater tanks. The sulfur, I found this at a local aquarium shop. They had tons of them on the shelf. Seems like a pretty common thing. You can order them online. I think it cost me about a tenner. And it's got a reasonably long life. I've had this one a couple of years and it still says 2021 on the expiry date. And you've got, I guess I think this is probably like a buffer or something like that, and then there's an indicator, and I'll walk you through exactly how you test your water. So the beer style I'm doing today, or I'm looking to aim for, is I'm doing a wheat beer, as I said, which when I'm looking on the list of beer styles and what to aim for, that seems to fall in sort of a pale lager, so from an alkalinity perspective up to 30 parts per million, and from a calcium perspective you want to be in a band of 100 to 120 parts per million. So those are the calculations that I'm aiming for today. I'm trying to get in that band. So yeah, let's kind of follow that through and I'll show you what I do. And there's a couple of little additional calculations. You get some instructions obviously with the kit, but there's a step to get between these instructions and the instructions that you might get from someone like Brew Packs, who are the people that I buy my 2 different water treatments from. Those 2 water treatments are CRS and DLS. Now, given I've got quite hard water, I don't suspect I'm going to have to adjust the calcium probably at all, maybe just slightly, but certainly the alkalinity of my water it's very hard, so I'll definitely have to adjust that. And I'll be using, as I said, CRS to do that. I'll also add some lactic acid at the end just to tweak the pH. I like to get my water to about 5.8 on the pH scale, because I find with a pale malt that should bring it down to around 5.3. I'm not too worried about hitting 5.2. I just want to get away from the sort of 7.4 pH that my base water is at. So yeah, I'll be checking those as I go along. I might not include that in this video, but those are some extra steps. Once you get this kind of adjusting the alkalinity and adjusting the calcium nailed, you can move on to other steps like looking at the alkalinity, etc. Looking at the pH. So the first step is to syringe 4 mils. So I've got a slightly larger syringe than the small one that comes with the kit. The small one comes with a kit you need to use. It's specially gradiated for when you're doing the measuring, but I'll kind of talk through that, and you need to take a measurement off of that. So you can, the kit does have a set of instructions. You can talk about halving the resolution by using less drops of the indicator, but I think it's only 4 drops. It's quite a large bottle, so I always go for the full resolution. So first off, what we need is 4 mils of the 4 mils of water from your raw water, effectively. So that's the tap that you're going to take your brewing water from. So I've got some water from my tap. Now, don't worry too much if I get an air bubble in here, because I just remember that this end of the syringe is full as well. So if you've got a little air bubble, it doesn't really matter too much. You take the 4 mil and you place it in that little vase, and you're or little sample jar, I guess, and now you're done with that. You don't need that again. So give the indicator a good shake, because if it's like mine, it probably sits around for quite a while. So I give that a good shake, and then what I want to do is put 4 drops into here. So you can see it kind of bowls up nicely, and you get nice drops off of it. So that's 2, 3, and 4. There we go. Make sure you put that top back on properly to give it a little bit of a swirl. You can hopefully see there what the colour's like. It's a sort of greeny colour. That colour will change significantly. And then we've got our sort of very fine measuring syringe. Hopefully you can see that. Don't get camera to focus. Which I'll put together. Again, you don't worry about the little air gap. There's going to be an air gap in the syringe, because obviously there's an air gap here. Don't worry about getting that out, because that's kind of accounted for in the calculation effectively. So don't worry about that when you see that, because the end will be full of liquid, and it will be that amount coming out of the syringe. As you go through it, you'll probably kind of work it out. But then we want this, which is the KH, and we want to fill that all the way to the 1 mil line at the top. Hopefully you can potentially see that. I don't know. Let's try to focus on the box at the back. Let's see if doesn't seem too happy about focusing on that. Take my word for it. That's gradiated at 1 mil. So we put the KH into the KH, and I just draw it all the way up, and then just push it back to 1 mil at the top. That's fine. And as I said, hopefully you can see there's a little air gap in the top there. Now that doesn't matter, because the the fact that there's no liquid in there doesn't matter, because there is liquid in there which accounts for that value. And effectively what you want to do now is you just want to count the number of drops as you drop in, and what you're looking for is for the indicator, and it should go a pink colour. So actually, let's see if I can get this a little bit of a better. So, and I'm going to count, so I'm not going to talk. So that's 25. The reason I count is because if you're adjusting, if you're having to come a long way down, you maybe don't want to go too slowly. You want to put maybe half in at the beginning. I don't know if you could see that. You were just starting to see some flashes of pink in the indicator, but they give it a little shake. I always do that halfway through. And you hopefully should start to see some little flashes of pink coming in. And as I get closer and closer to it changing, you can see when I swirled it then it all went pink, and now it's gone back to the indicator colour. So we're getting closer and closer. Okay, that all went pink again, hopefully you saw that. So now I'm just going to sort of add it a few drops at a time now. I don't want to overshoot it, if I can help it. Hopefully you can see that, that's gone, there you go, that's pretty much pink now. Hopefully you can see that. That's changed colour. And now what we're looking to do is read off where currently the syringe is sat on the gradiated scale, and then we go back to the instructions. So that gives me 0.025, pretty much bang on. Okay, so going back to the instructions, we read off of the little syringe how many millilitres were left in that syringe, and that gave us roughly 0.25, but I rounded it up to 0.26. So reading in millilitres was 0.26 millilitres left in that little syringe. So if we track that across to the right hand column, that gives us 4.10. So our alkalinity in MEQ per litre was equal to 4.10. So what we have to do then is convert that value so we can get it in the right format, and the right format is CaCO3. So we take 410 and we times that by 50, and that equals alkalinity in CaCO3. Which we know, I think, was 203. So let's just double check I haven't remembered the wrong number. So if we take 4.10 and multiply that by 50, oh, that gives us, sorry, I did remember it incorrectly, it was 5205. CaCO3. And from there, effectively, we know that if we're doing a pale lager, we want CaCO3 to equal approximately 30 parts per million from an alkalinity perspective. So what we know is we now need to get from 205 to 30. So that's pretty simple. We just subtract 30 from this. And that gives us 175. So that's, we need to reduce the alkalinity by 175 points. So there's a good guide that you can download from Brewing's webpage, which tells you Once you know these values, you know exactly how much you're going to reduce it. Effectively, it has a table here. This is for specifically working with CRS. And if we know we need to reduce by 175 points, we can look across the scale. The closest one on the scale is 160. And what we know is that if we're going to reduce by 160, we need to add that 0.87 millilitres of CRS per litre. So then we can just do a quick calculation for the amount of brewing water we have, and we can do 0.87, in my case it's 50 litres of brewing water, times 50 equals 43.5 millilitres. And that's what we would take from the CRS bottle, and that's what we would put into the brewing water to reduce the alkalinity down as close as we can to 30. In fact, actually, we're going to be, because we're using the scale, 205 subtract 160, that's going to get us to 45. So rather than our starting alkalinity was 205, we're going to be brewing with what did I say, 45. So we're much closer. Alkalinity parts per million will be 45. So that gives you an idea of what you're adjusting there. You can then take your original alkalinity, which in our case that we know is 205. And what we're going to do is now calculate the calcium addition we want to do. And we know for the calcium addition, for a lager malt, we want to be, calcium band, we want to be anywhere between 100 to 120 parts per million of calcium, if we're doing, again, a pale lager. So the way we work that out is we take the original alkalinity, which we know was 205, and we multiply that by 0.04. And that equals 82. So if we know the calcium, the current calcium content is 82, we want to be between 100 and 120. So again, if we subtract 100, subtract 82, we know we need to increase our calcium by 18 parts per million. So we can then look on the DLS graph, and the first one on actually is 16. So, and that on 16, so we're going to, rather than use 18, so we want to increase by 18 parts per million. So if we use 16, that means we need to add 0.1 DLS 0.1 grams per litre. There we go. So we then multiply that up, of course. 0.1 times 50 is 5. There you go. So that equals 5 grams of DLS for 50 litres of brewing water. And that should put us, you know, from an alkalinity and a calcium perspective, very much in band, or very close to the band that we need to produce those styles of beer. So that's just like a really quick run over of those two specific brewing additions that you can do. All of those things, you know, DLS and CRS can be picked up from your local brewing store, and as I say, the kit, the alkalinity testing kit, you can buy either online or from your local tropical fish shop. As long as they do saltwater tanks, then they should have those in stock. So hopefully that's useful. You know, if you've got any questions on it, give me a shout. There is loads of great guides online. There's a fantastic one on the homebrew forums that goes into a lot more detail, and there's some really complicated spreadsheets about almost tweaking every aspect of your water, you know, going to the point where, say, you use reverse osmosis or distilled water or something like that, and you're having to add every addition back in detail. I don't go to that length. These are the two main adjustments that I do. The other one that I do on top of that is make sure my pH is in band or close to in band. So yeah, hopefully this was helpful. You can see quite quickly that you can quite quickly and easily make these changes, and I always just document them into the brewing notes for the beer that I'm brewing, and you start to learn that actually if you're making an ale or a pale ale or something like that, that you need 0.6 CRS per litre, you know, and you don't even really think about it, you don't go back and do these calculations, you just know it's in the notes, that's what you did before for that style of beer, and then you can just make those additions quite quickly. And I always do them the night before, give the water a chance to settle down. Okay, cool. Have a great weekend, enjoy your brewing.